A contemporary study from Indonesia delved into the links between vitamin D levels and virus 19 outcomes, mobilizing 780 participants. These individuals were grouped based on their vitamin D levels: normal, insufficient, or deficient, a categorization accomplished by two medical practitioners utilizing existing clinical data. However, the specifics regarding the duration of recording and the treatment of absent data still remain ambiguous. Upon examining the deceased subjects, it was found that a mere 4% had normal levels of vitamin D, 39% were categorized as insufficient, and 47% were deficient. Contrarily, the survivors showed a drastically different trend, with a staggering 93% having normal levels, 7% classified as insufficient, and only 1% deficient. When the lens shifted to study the vitamin D levels instead of the survival status, a substantial trend was noticed. A shocking 99% of patients deficient in vitamin D succumbed to the infection, accentuating the need for deeper exploration into a potential correlation between declining vitamin D levels and escalating virus 19 mortality rates. It's crucial to assert here that we're not proposing vitamin D as a preventive mechanism or a treatment for virus 19, but we're presenting it as an idea deserving further probing. So, what exactly occurs in our bodies when we are deficient in vitamin D? Vitamin D is merely a vitamin. It's a hormone, responsible for regulating over 5% of the human protein, encoding human genome. That is a significant number of genes. To put it in perspective, imagine your body functioning without testosterone. And what is happening in the body that is causing our immune system and hormone deficiency by not having this vitamin D? Our immune cells have vitamin D receptors, and when the vitamin D hormone latches onto these receptors, it triggers a series of genes. These genes then regulate immune function. Moreover, vitamin D has a direct impact on how you age, from just being a steroid hormone. It governs the expression of over 1,000 different genes in your body that influence an array of physiological processes. The principal source of vitamin D is UVB radiation. Our skin has the capacity to produce vitamin D upon exposure. Even mushrooms can manufacture vitamin D when exposed to UVB radiation. Is it possible to have an excess of vitamin D? Absolutely. The Nutrition Board and the Institute of Medicine have established the maximum tolerable intake at 4,000 IUs per day. An optimal balance is crucial. When it comes to vitamin D, the sweet spot lies between 30 and 80 nanograms per milliliter of serum. According to the CDC, only 30% of white-skinned Americans maintain these optimum levels. This statistic is lower for those with darker skin. The most effective and safe method is to elevate your vitamin D levels is through your diet. Fish, in particular, is a rich source of vitamin D. Regular testing your vitamin D levels can assist in fine-tuning your supplement intake. As you age, your vitamin D production decreases, with a 70-year-old producing 4 times less vitamin D than a 20-year-old. Your body fat can also impact the availability of vitamin D. The higher your body fat, the more vitamin D gets stored in that fat, and lesser of it is released into your bloodstream. Vitamin D is more than just a vitamin. It's a steroid hormone, integral to our bodies. In a study comprising over 25 control trials, people with low baseline vitamin D levels were given varying doses of a vitamin D supplement, either weekly or daily, because monthly did not work. People that were deficient were over 50% less likely to have a respiratory tract infection. Even those with normal levels benefited, being 10% less likely to have a respiratory tract infection. Another studies on twins indicated that individuals with the lowest vitamin D levels also had the shortest telomeres, correlating to 5 years of biological aging. It's believed that vitamin D's anti-inflammatory properties might play a part in the attrition of telomere length. Telomeres have tiny caps at the end of your chromosomes that protect your DNA from damage. You can sort of think about telomeres like the tips of shoelaces. They protect them from fraying every year. Our telomeres get shorter and shorter until eventually they burn off, and our cells die or go into a permanent state of arrest. In one animal studies, mice genetically engineered to disrupt or increase vitamin D, resulting in premature aging and a shortened lifespan. This underscores the importance of maintaining optimal vitamin D levels, underlining the need for routine testing to achieve that sweet spot and to fine-tune your own vitamin D level. These study highlights vitamin D's crucial role in health, impacting immune function and aging. Maintaining optimal levels is essential, emphasizing the need for routine testing and supplementation. The findings encourage further exploration of vitamin D deficiency's broader implications, prompting research into its role in respiratory health, immune system regulation, and overall well-being across all age groups. Thank you for watching. If you found this video helpful or informative, I'd greatly appreciate your support. Please consider liking, commenting, and sharing. Your engagement helps the channel grow and allows me to create more content like this. Thanks again for tuning in, and I'll see you in the next one.